In this video, we're going to write the equation of a hyperbola centered at the origin in standard form. It says, what is the standard form equation of the hyperbola that has vertices 0 and then positive 5 and 0 and negative 5 and foci 0 positive root 61 and 0 negative root 61? So let's define that if we're talking vertices here, that this distance right here, this is A. So A is going to equal 5. And this is C because we're talking foci, so C is going to equal root 61. Now, I want to graph this just a little bit to see what kind of orientation we have here. So we have 0, 5, and 0, negative 5, so that'd be 1, 2, 3, 4, 5. So that's one vertice, 1, 2, 3, 4, 5. Here's the other vertice. So if our vertices are like this, then that tells us that we are opening down and we are opening up. Now, what does that tell us? Well, that tells us that if we're opening down and up, that the y variable is the first term. And now, if you have the x variable, so this is something to keep in mind, the x variable, so I'm going to say if the x variable is first, then you would have opening left and opening right. Okay, so we don't have that. We have this scenario. So we're going to have this one right here, which has a y variable as the first term. So our equation needs to look like y squared over a squared minus x squared over b squared is equal to 1. Now, I have C and I have A, and for hyperbolas, we can use C squared is equal to A squared plus B squared to find B. So we can say that we have root 61 squared is equal to 5 squared plus B squared. When I square this, I get 61 equals 25 plus B squared. Subtract the 25, and that would give you 36 is equal to B squared. So now that I know that B squared is 36, and I know A is 5, so A squared is 25, I can substitute those in and say y squared over 25 minus x squared over 36 equal 1. This is our equation for our the hyperbola. And that selection would be the first selection in that group.